Extra energy requirements. Extra energy requirements refer to the additional caloric intake needed by the body beyond the basic energy requirements, basal metabolic rate or BMR, for certain physiological conditions, activities, or life stages. These extra energy needs stem from various factors including physical activity, growth, pregnancy, lactation, illness, injury, and environmental conditions. Understanding these additional energy demands is critical for ensuring the body has enough fuel to maintain optimal health and function under varying circumstances. Physical activity. Physical activity is the most common factor contributing to increased energy requirements. The body needs extra energy for any voluntary muscle movement, ranging from light activity to intense exercise. The extra energy required varies based on the type, intensity, duration, and frequency of physical activity. 1.1 Types of physical activity. Physical activity can be categorized into different levels, which correspond to different energy expenditure. Sedentary activity. Very little to no physical activity. Examples include office work, reading, or watching TV. Extra energy requirement is minimal. Activity level factor PEF is around 1.2. Light physical activity includes activities like light walking, household chores, or light exercises. Extra energy requirement is moderate. Activity level factor PAF is around 1.375. Moderate physical activity includes activities like brisk walking, cycling, or moderate exercise. Example jogging. Extra energy requirement is higher. Activity level factor PAF is around 1.55. Vigorous physical activity. It includes intense activities like running, heavy lifting, or competitive sports. Extra energy requirement is significantly higher. Activity level factor PAF is around 1.725. Extreme physical activity includes professional athletes, laborers with heavy physical work, or individuals who engage in intense training multiple hours a day. Extra energy requirements are the highest, and activity level factor PAF can up to 1.9. 1.2 Energy expenditure during exercise. Energy expenditure during exercise can be estimated by multiplying the duration and intensity of the activity by the energy expenditure rate, which is typically measured in kilocalorie per minute. For example, running at a moderate pace, 5 mph, can burn approximately 300 to 400 kilocalorie per hour for an average adult weighing 70 kg. High intensity exercise like running at 6 mph could burn up to 600 to 800 kilocalories per hour depending on the individual's weight and metabolism. 1.3 Estimating total energy expenditure TEE. To calculate the extra energy requirements due to physical activity, the total energy expenditure TEE is derived from the equation TEE equals to BMR into physical activity factor, where physical activity factor varies based on activity level as outlined above. Point 2. Pregnancy. Pregnancy is a period of significant physiological change and the body requires extra energy to support fetal development, maternal tissue growth, and metabolic changes. The extra energy requirements vary by trimester, with the second and third trimesters having the highest demand. 2.1 Extra energy requirements during pregnancy. First trimester, energy needs increase slightly. The extra energy required is generally modest, about 100 kilocalorie per day. Second trimester. The growing fetus, placenta, and maternal tissues need more energy. The extra energy requirement is approximately 300 kilocalorie per day. Third trimester. This is the period of the most rapid fetal growth. Extra energy requirements may be as high as 350 to 450 kilocalorie per day. 4.1 Extra energy requirements during illness. Fever. For each degree Celsius increase in body temperature, energy expenditure increases by approximately 7 to 10%. Infections. Illness like bacterial or viral infections increase metabolic rate. The body's immune response requires additional energy to produce antibodies, white blood cells, and to carry out other defense mechanisms. Estimates. Energy expenditure during a fever can increase as much as 200-300 kilocalorie per day, depending on the severity of the illness and fever. 4.2 Energy requirements in specific illness. Chronic illness, example cancer, HIV, AIDS. These conditions can cause catching muscle wasting, leading to increased energy expenditure and may require a higher caloric intake to prevent weight loss and malnutrition. Surgery and trauma. Recovering from surgery or trauma requires additional energy to heal tissues, fight infections, and recover muscle mass. Point 5 Growth. Children and adolescents. Children and adolescents have higher energy requirements than adults due to rapid growth, development, and high metabolic rates. Energy is needed not only for physical activity but also for the energy intensive processes of growth and development. 5.1 Extra energy requirements during childhood and adolescence. Infants and toddlers 0 to 2 years. Energy requirements are very high per unit of the body weight, with an average daily intake of approximately 80 to 120 kilocalorie per kg. Preschool and school age children 3 to 12 years. Energy requirements are lower than in infants but still higher than in adults. For example, a 6-year-old child may need around 1200 to 2000 kilocalorie per day, depending on activity level. Adolescents 13 to 18 years. The growth spurt during puberty increases energy needs. An average adolescent may require 2000 to 3000 kilocalorie per day, with males generally requiring more than females due to greater muscle mass and size. 5.2 Key nutritional considerations during growth. Proteins critical for tissue growth and muscle development. Carbohydrates and fats needed to support the energy demands of growth and physical activity. Micronutrients essential vitamins and minerals, particularly calcium and vitamin D for bone growth and iron for red blood cell production. 6. Environmental conditions. Extreme environmental conditions such as very cold or hot climates can also lead to extra energy requirements. In colder environments, the body uses more energy to maintain its core temperature, while in hot climate, the energy may be expanded in cooling mechanisms, including sweating. 6.1 Extra energy requirements in cold environments. Shivering thermogenesis. In extremely cold conditions, the body burns additional calories to generate heat through muscle activity. This can increase energy expenditure by up to 50% or more. Non-shivering thermogenesis. Brown fat activation for heat production may also increase energy expenditure in cold environments. 6.2 Extra energy requirements in hot environments. Heat stress. When the body is exposed to high temperatures, it uses energy to regulate internal body temperature through mechanisms such as sweating, which leads to fluid and electrolyte loss. Increased fluid intake. Hot environments increase the need for water and electrolytes, which indirectly affect energy requirements as the body prioritizes hydration. 7.1 Extra energy requirements in the elderly. Elderly individuals with chronic illness, infections, or those recovering from surgery may experience increased energy requirements. Maintaining muscle mass and overall health in older adults may require an increased intake of protein and calories, especially if they are frail or malnourished. Conclusion Extra energy requirements are influenced by a variety of factors such as physical activity, pregnancy, lactation, illness, growth, environmental stress, and aging. Meeting these increased energy demands is critical to ensuring that the body has enough fuel to maintain its essential functions, support recovery, and promote growth. Tailoring energy intake to specific needs, whether for athletes, pregnant women, or individuals recovering from illness or surgery, is vital for maintaining health and well-being. Understanding these factors help in developing balanced diet and optimizing nutritional strategies.